Hello everyone, this is Mr. Newman here, and we're going to learn about solving equations. First thing I want you to notice is, let's jump right into this problem here, is isolate the variable. So the word isolate means to get it by itself. So this isolate the variable means to get, in this case, x by itself. In order to do this, we're going to undo the operations one at a time. In other words, we're going to work backwards, okay? So let's look over here at our problem. I made it a little larger here on the right for you. That first operation is adding 2, 3x plus 2. We want to undo that operation. So in order to undo it, we're going to subtract 2. The opposite of adding is subtracting. So I subtract 2. And then we get to our next big important idea. Whatever you do to one side, you must do to the other side. Okay, you must do to the other. So if I subtract from the left side of the equal sign, I also have to subtract from the right side of the equal sign. Now some people like to draw a little vertical line there. Sometimes I will, sometimes I won't. I won't count you off if you don't, but if you start getting the sides mixed up, I would highly recommend you do that. So let's subtract 2 from both sides and write down what we get. We still have 3x. 2 minus 2 is 0, so I'm not going to put anything there. 3x equals 20 minus 2 is 18. The next operation we have, 3x, it's not written there, but anytime you have a variable right next to a constant like that, that means multiplication, 3 times x. So in order to undo multiplication, we need to divide. And we're going to divide by 3 on both sides. When you divide 18 by 3, you get 6. Now one thing you're going to find in this class is you always need to check your work. If you don't check your work, you don't know if you got it correct or not, and it saves a lot of time later on. So I'm going to show you how to do that. On these, since we got an answer, x equals 6 for the x, we're just going to plug it right in there for x, okay? So let's rewrite it. 3 times 6 plus 2. And we want to see, is this equal to what we said it was in the original equation? In the original equation, we said it's 20. And sure enough, 3 times 6 is 18, plus 2 is 20. You can type that in a calculator to check it, or just write it out, but we just checked our work and we now know that that is the correct answer. I want you to pause the video right now and try these 2 problems. Resume the video when you are done with them. Alright, next we have a few tricky examples. First I want to point out that x with a line over the 4, that's division. That's the same as saying x divided by 4. In fact, you never see this division symbol here hardly at all anymore. So yeah, let's just move on to using fraction bars. It's a lot faster anyway because you just have to draw one line instead of 2 dots in a line. But yeah, that's division. And I'll show you how to do these and we'll talk about why it's tricky. So I'll put my line there for this time. I want to subtract 2 from both sides because that's the last thing that happens on the right there. And when I do that, I get 4 on the left equals x divided by 4, or x over 4. Now if that's division, the opposite of division is multiplication. So I'm going to multiply both sides by 4. And whatever you do to one side, you have to do to the other. So multiplying by 4 eliminates that 4. So we undid the division, so there's just an x on the right now. On the left, 4 times 4 is 16, so I got my answer, x equals 16. Let's go ahead and check it. We want to see, is 6 equal to, when I plug in 16 for x, over 4 plus 2? Is that true? And so I'm just going to compute 16 over 4 is 4, and 4 plus 2 is 6. Lastly, this last problem here is also tricky. You see, the last thing that's happening on the left there is actually dividing by 3. So the first thing I'm going to do if I'm working backwards is I'm going to multiply both sides by 3. We'll take care of the 9 later, but I need to get rid of the 3 first before I can deal with anything inside of a fraction. So when I multiply by 3 on the left, the 3's divide out and we have z plus 9. That equals 8 times 3, which is 24. Now I can draw the line here again if you'd like. We need to undo adding 9, so I'm going to undo it by multiplying, or by subtracting 9. And when I subtract 9 from both sides, I get z equals 15. I'm going to check this real quick over here on the right. And again, you can pause the video as much as you need to get caught up on the writing. So what in the world happened there? It seemed like on the left we did subtraction first, and to undo the addition, and on the right, we did multiplication first to undo the division. Well, this has to do with the order of operations. Whenever you're undoing operations, you go in the opposite order of doing the operations or evaluating it. So let's just remember our order of operations. You can remember, in my class I teach GEMDOS. Some of you may have heard PEMDOS before. So GEMDOS means grouping that can include parentheses, which is the P in PEMDOS. E is exponents, M is multiplication or multiply, D is divide, A is add, and S is subtract. And really we should have brackets around the M and the D because they go together. It's really whichever one happens first. And then the A and the S also should go together, addition or subtraction, whichever one happens first on the left. So whenever you're doing or evaluating an expression, you move to the right. You do grouping first, then exponents, then multiply and divide, and then addition and subtraction. But when you're undoing it, you need to work backwards. You go the opposite direction. So if you see any addition or subtraction, you work backwards. Now, but wait, you say, doesn't that mean we should subtract 9 first here? Well, what you don't see is that this z plus 9, since it is on top of a bar there, that is actually grouped. So it's as if there were parentheses hidden right there on top of the fraction bar. Because of that, that puts grouping as the last thing we should do, so we really should take care of that 3 first and then deal with the grouped z plus 9. All right, I want you to try these 2 trickier problems now, and we'll see you in class.